Hello. Hope you had a good lunch. My name is Beni. I'll be talking about code reloading into an already running interpreter. I have too much material for 20 minutes, so you can find more links and details in this repository, the slides, and I also put more notes there soon. So start with motivation. Why do I care about this? A very common situation, at least for us developers, is that we are in the middle of using some code, and then we decide to change it because we want to debug it, because we want to try implement it differently. So we all know the kill, edit, and restart from zero cycle. Sometimes it's great, sometimes it's very tedious to reproduce the exact state you were in. The alternative I want to talk about is updating the code in an already running interpreter without losing any state, and hope you don't screw up. It has downsides too. And this has been both technical division. In some languages you can't really do this, but in most interpreted language to some degree you can, but also a somewhat cultural division. To give you an appetite, I want to take you back to the historic demo. The year is 1979, and Jeff Raskin and Steve Jobs come to visit Xerox PARC to see this this thing, which we now call a graphical user interface. And to me, one of the coolest part of the demos I saw was not just the interface that is polished and friendly and pretty, but the Smalltalk environment that allowed PARC to make it polished and friendly by iterating rapidly, sometimes even in front of users. So they saw changes like how selection is drawn and some how scrolling works. And specifically, Steve Jobs asked about scrolling, that it is discrete, line by line. He asked if it could be made continuous. So Dan Ingalls already had his code browser open, and under text objects in the text image class, even he found this method scroll up. Need to scroll to get to the scroll method. Here, I don't know if you can see, but n divided by self-line height is, turns out it was doing an integer division. And by adding s, is it, the f should be capital. I think. Okay, I think. And doing right-click compile, it was changed. So now, without changing anything, without losing any change, it is scrolling continuously. Don't get confused by the term compile. On original hardware, it froze the system for like 10 seconds, but it's not killing and restarting it. It's just updating the bytecode for a single method, and all the state is still retained. So now we are 46 years later. If this makes you a little bit envious, good. Some languages like Lisp, Smalltalk, Self were really designed for this kind of workflow. Ruby inherited it a bit from Smalltalk, Python less so. Python is sufficiently dynamic, has sufficient reflection to be able to do these things, but there are some pitfalls and you need to understand what you're doing. The idea of this lecture is that it's not exactly a one-size-fits-all approach. You better understand the limitations and how it works. I'll be skipping some things because otherwise I will not fit into 20 minutes. But for me, there is also an ideological angle to this. We are not there yet, but in an ideal future, I believe users should be able to change any software they're using, inspect it and change it right in the middle of using it. Not having to switch to an entirely different set of tools is probably one of the elements that is needed to make that at least closer to possible. I came to do this a lot in the last year because I was trying to play with a window manager that is written in Python, written by Jonas Boscher. It's unfortunately abandoned, forked, abandoned again. The community is very small. I don't know if I can recommend it, but I wanted to hack on a window manager. And it's a Wayland compositor, so in X Windows you can replace the window manager while keeping all your windows. In Wayland, the compositor is the parent of all the processes running on your desktop. And if you kill it, you lose all your programs. So the kill, edit, restart cycle was really a bad fit for me, and I really needed this. And that window manager already is taking the shortcut of not having a separate config format or something. It's just importing a Python config.py file that you write, and it's reloading it. So I extended it to also start reloading the code base of the window manager itself. I also found ways to connect with Jupyter. That's why the repo is called IPy window manager, because it's like IPython plus window manager. So I'll have some more notes there about this workflow. Some of it is more crazy, less crazy. Anyway, let's get to the technical stuff. First, we'll talk about things that are applicable to anyone working in the REPL on Jupyter. This will be useful also because when you reload a single file, the semantics is very similar to just redefining things in the REPL. So the first section is useful for both. Let's talk about a really basic thing. In Python, if you define a function that refers to, does a forward reference to another function, obviously you can't call it right away, but if you first define the other function too, and then you call it, then it works. We don't usually worry about order functions. We just write them in whatever order we find readable for the specific application or project conventions, top-down, bottom-up, by topic, whatever. And this is also great for redefining code when working at the REPL or for reloading code later, we'll see too. Because if f is calling g, the actual lookup, there is no like linker like in C or something where there is an actual pointer to a specific implementation of G that is embedded in F. It's just a load global instruction. It's looking up at the model of execution. So if I just redefine G, I don't have to touch F. F will automatically use the new version of G. So that's great. An important thing about def, a very important thing for our purposes, is that def always creates a new function object. It doesn't, even if function with the same name was already defined, here I'm defining G, I'm copying it, the pointer, and when I define G again, the last def, you see that you get a new pointer to a new G. You have now two function objects floating around. Here is a good opportunity to tell everyone if somebody doesn't know Python tutor, it's a great thing. That's how I made half the diagrams here. It does automatic step-by-step box and pointer diagrams for the whole execution of your code. It has limitations. It's basically for small educational code, but still it's very useful. And it's, despite being called Python tutor, it also works for other languages. In C++, you can even see buffer overflows. Pointer will actually go from one object into another object. It's very impressive. So Python tutor is cool. I'll skip this. OK, so I told you that, I forgot to tell you that what we saw is that you can just redefine a function you refer to by name, and it's you get immediately use a new version. That's what's called late binding. And that's great for us. But there are many ways in Python in which you can get bound to a specific reference to a specific function. In this example, if you look at where the hand is pointing, I'm capturing G in the default arguments. You can see it in the graph. The F has default arguments, and it's pointing to a specific G. And if I redefine G, If I redefine G, I get the global G now points to a new function, but F is still pointing to the old function because it captured the specific reference. And there are tons of scenarios by which you can put functions in data structures. You can have them in locals. You can have them copied to another module by from module import. And in all these cases, you can get a problem of you define a new version of the function, but you're still calling somehow the old one. I'll get later to how to big approaches to handle this. Now I wanted to show a couple tips. There is a nice pattern if you have some initialization code that you only want to happen once. Maybe less useful in the REPL, but useful also in Jupyter and in files. When a particular global, you want it to be a singleton, you want it to be a persistent depend-only object like here. You don't want to lose it when you re-execute all your code. If you take care to treat the code you only want once specially, then you can just, like in Jupyter, can do run all cells without restarting the kernel. Obviously, you can restart the kernel, but that's the kill and start from scratch approach. And it works by just trying to access the name. First time around, the name is not defined, so you do your initialization in the except name error branch. Second time around, its access works, so you do nothing. A caveat that I want to warn you about when you're doing redefinitions and reloads is that renames are risky. They can easily bite you. Here, I'm renamed x to y, but I forgot to update the reference. The function is still referring to x. If I execute the code from scratch, if I kill it and start from scratch, I will properly get a name error exception. I'll know I have a bug. Unfortunately, because we are evaluating in the same namespace, the old x still exists. The fact I change it in my code, executed my cell or change it in my file, doesn't tell Python to delete the old definition. Unless I write explicitly del x, I can easily use the old one, and it's a silent problem. Because that is not a problem in your code, it's a problem that this workflow introduces. So be careful about renames. I'll skip this. OK, I told you that def creates a new function. A class also creates a new class object. I don't want you to go to all the details, but you can see in the graph, you can see a class instance that is pointing to a class object. And the specific method that comes from that class. And if I repeat all this code, I define the class again. I instantiate the class again. I call the new method on the new instance pointing to the new class. I get a whole separate hierarchy of objects, duplicate. So it's similar problem to the functions. I can, if I replace the same names, and if I have no pointers remaining to the old objects, then great, it just works. But frequently, a big part of retaining my work state, which is why I'm going into this workflow at all, is that I want to retain existing instances, but I want to change their because they already contain a lot of the state in my project, but I want to upgrade them to the new behavior. And this way, this will not just work, because an old instance is pointing to an old class object. I just pointed the global to the... In the global frame, you can see C is pointing to the old class, and now it's pointing to the new class. But the instance still points to the old class. So, OK, let's progress to reloading a file. And later, we'll see extra complications from multiple files. Python forever has this built-in function. It used to be in Python 2, it used to be just top-level built-in. Now it's in portlib. But it is not quite sophisticated enough to solve the complex cases. But it is important because it set a tradition. The tradition is that when you reload a module in Python, you do it in the existing module object. Sys models, square bracket something, points to a specific object within a specific dictionary. And whenever you import your model to another model, you get a handle to that model object. So executing the new code in the old model object is good for us. We don't get two separate models. We get the same one, and all pointers point to the single same model. It just now has a new updated namespace. The second decision was not to clear it out. When you start the reload, you get access to your previous, all the previous values. It has a drawbacks, like I told you with three names, you can incidentally call an old name. But it has the benefits like the name error try pattern, where you can detect whether you're running the first time or a second time. So in this way, what you do with reload is quite a similar mirror to what happened with just redefining in the REPL. So to summarize, new function is a separate object from an old function when you do def. Class is a separate object, but the model is the same model. And already there is a silly difference. It depends on the style you write your code. If you just call model.something, you get access automatically to the new things you defined, because it's the same model. But if you do from model import, you get a copy in your model that is still referring to the old things. And that's annoying. So the big dilemma of all the libraries that try to do better reloading is what do you do with when you have pointers to an old object and you have a new object side by side with it. And one approach is to patch the original object to behave as much as possible equivalent to the new object. So it doesn't quite matter where you point. It doesn't always work, but surprisingly it works quite okay, and most libraries do this. Another approach is to update all pointers from the old to new. We'll get to that soon. When you have multiple files, you get an extra complication. Suppose that A imports B, imports C, imports D, and now I just want to edit D. I change something in D. Just reloading D might not be enough because A, B, and C might include top-level initializations, object construction, things like that that depend on specific things that were in D. So generally, the most robust thing is to reload all of them in reverse dependency order, starting from D. And that means that libraries may want to track the dependencies. So how can they track the dependencies? There are a few mechanisms. The best one is the old __ import global hook, which allows you to override all import statement executions. Even if this model is already in sys.models, the behavior that if it's cached, the import is do nothing import is just the default. But if you redefine this global hook, you can force it to do a deep reload, to reload the already loaded model anyway. So you can switch to this recursive mode around your specific reload you want to do. Then you start from A, and it will automatically reload B and C and D, and then get back to A. So that works nicely. There are some less good approaches, and some libraries also pick at actually parse the source code and look for import statements and try to figure it out statically, which is not always possible in Python. Specifically, if you, there is also an approach of dropping things from sys models and doing import again. That forces it to reload the file, but that creates a new model separate from the old model. That's just more headache. At least this part was, and also the try name error won't work. It breaks the tradition, and I think it's libraries which do that are less good. So, okay, if you want to update pointers, how do you even do it? How do you find objects that point to a specific thing? In CPython, there is a magical function in the garbage collection model that kind of traverses pointers in reverse. It's kind of impossible. It does it by actually iterating over all the objects that participate in garbage collection. So it's kind of slow. It's also a bit risky. It might, in some situations, there are known cases where it can expose still under construction objects that are not supposed to be visible and can actually crash CPython. Been so for years and it's not going to get fixed probably. Officially, it's just for debugging. Don't use it in production. But many of reloading libraries use this. The one quite safe use of it that everybody does is to find all the objects that point to a class, check if that class is their type, and then you can update the class. So generally, the patch approach is you have a old behavior, old class, or old function, and you can update. In case of classes, you update, copy the dictionary. So both the old class and the new class have the same dictionary and behave almost the same. In case of functions, you can update the code pointer. So they won't execute the new code despite being two separate functions. And this way, you don't actually care much if it's the old pointer or the new pointer. And some libraries do both of them. See, I don't have time. So you can look more in the presentation, but I'll mention quickly. Limeade is not active anymore, but it's quite a compact library. If it's well written, if you want to read it, I can recommend it. It has some nice techniques. There is a library that even does C extensions to mutate things to patch. Like I told you, you can patch code objects on functions. There are some attributes in some situations that you cannot patch. Somebody made an experimental extension to patch them still. The two biggest libraries are JURigged, which has some nice workflow things, and what's important to say? Yeah, okay. A very important thing about all libraries is enable verbose logging. Because of the complications that you might sometimes not be running the new code as you expect, it's much safer to do these things when you see what the library is actually decided to do, what it's updating, what it's replacing, when it's even reloading your module or not. So enable the verbose. In IPython, there is auto-reload, which is very comprehensive. It combines several of the techniques. It does both the update where possible, both the patch pointer, both the patching wherever possible. It does ST analysis to try to find the from import, but only in the REPL itself, not in the modules from modules. It also has a dependency tracker and the stdiff. And there is some ability to use it outside of IPython with less integration, but you can try it. You would hope I can now tell you which library is the best, but actually I don't have enough experience with them because I used my own hand-rolled code to using these techniques, which was okay for my specific project in that window manager. I added a lot of print so I can see exactly what it's doing. Generally, you should start from the one of the shelf libraries, especially JURigged, or if you are in the IPython Jupyter, just try the auto-reload. See if it works for you or not. Enable the print or verbose options. By this point, maybe some of you have an impression that this is great, I want to do this, and some of you think this is horrible, I don't want to get anywhere near that. And that's actually good. You learn something, and now you know I don't want to do this. If you take a step back, I recommend everything by Brett Victor, but this specific Inventing on Principle lecture tells you what we really want is fast feedback. It doesn't tell you how to get fast feedback. And there is a whole other world of approaches where you do the kill and restart, but you try to do the compilation fast. You try to do deterministic replay of the work you did previously. And generally, whenever you work in TDD style and you iterate on tests instead of on manually exercising your software, this is what you're doing. You're streamlining the deterministic replay. And this is great. And I have some more wider resources to share here. The Live Prog workshop. Academia kind of neglected this for the last 2 decades, but Live Prog workshop is excellent, and they have a live primer document that summarizes a lot of this. And there is also one thing I recommend you to watch, Google for live coding music. There are people just mutating the algorithm, synthesizing the music as it is playing without stopping it. It's crazy, way above me, but it's very impressive. And if you care about making software more accessible to users, the Malleable Systems community. That's it. Thank you.